What OpenAI realized before basically everybody but DeepMind was that the next phase of AI after Transformer was not going to be about research paper writing. It was going to be about, let's choose a major unsolved scientific problem and just try to solve it. The second way of improving model performance is just starting to be tapped now, and that's also going to absorb a boatload of compute. So because of that, I actually am not worried about diminishing returns to compute over time. I think every tier one cloud provider existentially needs to win here.
Ready to go? David, I am so excited for this. I've wanted to do this one for a long time. I've heard so many good things. So first, thank you so much for joining me today.
Yeah, thanks, Harry, for having me on it. I've got to watch some of your cool previous episodes, so it's a real honor to be on here.
And that's very, very kind of you. I really do appreciate that, man. But you've been at some incredible companies as a training ground, so to speak, one of which was Google Brain. And I just wanted to start there. When you think about your biggest takeaways from your time with Google Brain, what would you say 1 to 2 are? And how do you think that shaped how you think about building Adept today?
Google Brain was, and also now as part of DeepMind, is a really magical place. It's the, I think during the peak days of AI progress on the research side, right, where every day there was a new paper that came out that would just change the world, that like 2012 to 2018 or so era, Google Brain was just like incredibly dominant. They did an amazing job picking talent, like the people who invented Transformer, the people who invented the diffusion model, people who did all of these new optimization techniques that we all take for granted today. They were all at Brain at the same time, like truly the Bell Labs of the era. And I think I learned a lot about how to make pure bottom up, like to see what good pure bottom up basic research looks like at Google Brain.
What does that mean? What pure bottoms up good basic research is?
Yeah. So I have this worldview of AI progress as being a part of a couple different phases, right? And I like to think about pre-2012 as basically being prehistory. Of course, all of the OGs in the field would probably not like that if I characterized it that way. But before 2012, like most of the things we tried just didn't really work, right? Like you had things like a sheep being identified as cats and dogs, and chatbots that barely said anything coherent, et cetera. But I think like there was a period between 2012, like 2017 or 2018, where deep learning went from something that people didn't believe in to being like the dominant paradigm in the field, right? And so during that 2012, 2018 era, the way people made progress, what I mean by bottom-up basic research is you hire the most brilliant scientists, they come to work every day with like no near-term objective they're being held accountable to. And they just work together and they think about, like, I wonder what it'd be like if we could solve this like open technical problem in AI. Like, how do we create a model that better understands how to generate images? And they just go work on that of their own curiosity and drive and maybe some interest in glory and fame through papers. And they do that for they do that for like 6 months or so, and then pops out this like research paper that gets posted to archive and goes to a journal that like just solves the problem. Like that's huge, right? And so the reason I call it bottom up is because it's just driven by the natural interactions between all these researchers in a setting, and they figure out what they want to do.
And then what's the next wave then? You had that 2012 to 2018. How do you categorize the next wave?
Well, I think what happened was in 2017, the Transformer came out. And I remember I was running engineering at OpenAI at the time, and I was working really closely with Ilya. And Ilya and I were just sitting around, and he was just like, look, this Transformer thing is real. It's going to be the next most important thing. Let's get all of our teams looking at how we can use this thing. And so the thing that most people in the general public don't know about is we didn't invent Transformer at OpenAI. It was invented at Google. But what Transformer did though was it was the first time you had a model that was sort of generally applicable to any machine learning task, right? Like back in the day, if you wanted to understand images, you used a convolutional neural network, right? Like AlexNet. If you wanted to understand, if you wanted to generate text, you used RNNs. If you wanted to beat humans at Go, you used a tree search or RL, right? So you had all these different models that you would use to solve problems in AI. And then Transformer kind of became like the universal model and like the base element of AI that came out at that time. And once Transformer came out, in a weird way, you kind of stopped needing to go stop needing to go make like super low level breakthroughs in modeling, because it kind of just worked for everything. And then you got to go take that thing to solve really, really big problems.
The show's been successful because I'm not afraid to ask stupid questions,
Shoot.
Which is very uncharacteristic of VCs. But 2017 Transformers, what a breakthrough.
Yeah.
But ChatGPT seems to be the consumer breakthrough that we all waited so many years for. What was the reason for that chasm between Transformer breakthrough and consumer adoption breakthrough with ChatGPT?
Yeah, no, that's a really good question. It's kind of like ChatGPT was like the frog that ultimately became boiled, right? Like Transformer was a huge breakthrough, and every incremental year from 2017 to when ChatGPT came out, language models just got a little better and a little better and a little better. Like I remember Alec Radford and a couple others, and I did GPT-2, right? And GPT-2 came out in, I think, 2019. I just remembered, this finally you had this like pretty smart generalist model that you could just say, hey, like write me a newspaper article about insert celebrity being arrested in LA, and it would just do a perfect job. You'd be like, oh, they were in like the Neiman Marcus store, etc. I thought that was so much fun. But like the thing is, like two things had to happen. One, the models weren't getting increasingly smart, but there's like a minimum viable smartness where you're like, damn, this is a compelling experience. And the second thing was it needed to be packaged up in a way that consumers could play with. So if you go look at the lag, right, ChatGPT was really just GPT-3 with instruction, basically like more chat tuning. But GPT-3 API came out, I think, over a year before ChatGPT did, but only developers could play with it. So there was no viral aha moment for consumers. So the packaging and the intelligence had to exist in order for that virality moment to happen with ChatGPT.
We mentioned ChatGPT there. Before we dive into the meat of the show, I do just have to ask, you mentioned your time with OpenAI. It's such a transformative place to be. You mentioned working with Ilya there. What's one or two of your biggest takeaways from OpenAI that really informed how you think about building Adept?
Well, the first one actually is, and going back to the like eras of AI discussion we were having, right? What OpenAI realized before basically everybody but DeepMind was that the next phase of AI after Transformer was not going to be about, research paper writing. It was going to be about, let's choose a major unsolved scientific problem and just try to solve it, right? And so like that led us to go build a culture. Instead of like loose collections of federations of researchers, let's put a giant team around how do you solve like robot hand control. Let's put a giant team around beating humans at like one of the most popular video games on the planet, right? Let's put a giant team around scaling GPT until this thing is like a generalist reasoning and chat engine. Like that's just a totally different framework from like this very academic, curiosity-driven research. And I think that that's the right framework. And I think it's a big part of how we build Adept now as well.
So it's the focus of large groups of scientists on specific real-world problems, not on scientific paper creation?
Exactly. So it's like the switch from like building, hiring like 1,000 people to go sit around thinking about how to put together small rockets versus like creating like the Apollo project, right? It's a lot better to say, hey, our goal is to go to the moon, and we're going to hire however many people it takes to go solve going to the moon. It's very different than just like a giant mass of people organically self-organizing to do.
I'm interested. You said earlier about kind of the transition of models. You mentioned GPT-2, moving to GPT-3. When we think about model performance today, people are starting to say we're seeing diminishing returns, that more compute does not lead to better performance. I interviewed one of the most prominent people in AI the other day, and they said that OpenAI was actually disappointed by the lack of performance that throwing more compute did to their latest release. Do you think we are seeing diminishing returns now? More compute does not lead to more performance?
I don't think so. And here's why I don't think so. So it all depends on what axis you use, right? So the way that giant model scaling works historically, if you go look all the way back to GPT-2 to GPT-3 to 4, et cetera, the way it's worked is that let's say, just to use a reductionist analogy, every incremental GPU you throw at the problem actually does have diminishing returns, but every doubling of GPUs you throw at the problem has very predictable, consistent returns. And so it's kind of like a logarithmic curve versus a straight line, right? Depending on what axis you use to go look at it. So put another way, for just scaling up a base language model, you need to double the amount of compute for that language model for it to be predictably consistently smarter. Does that make sense?
It totally does. So it's like, okay, actually, there's a lot more room for improvement with the increase in compute availability that we should and will have.
Yes.
I had Alex Wang on the show, and he was like, it's not algorithms, it's not compute, it's data that is the bottleneck to AI model performance.
Yeah.
How do you think about that? Is that true?
So let me put it a different way. I think that I am not a lawyer, but even so, I will say it depends. And so I think the better way to go think about it, in my view, is like there's two parts to model scaling with compute. One part to it is you simply make the model bigger and then you throw more data and more GPUs at it. If we go look at CPUs in data centers, right? For a long time, we had Moore's law, right? Every year chips would get better at some predictable pace. And everybody's like, Moore's law is going to die. You know, we're at 3 nanometers or whatever. There's like no more nanometers left but what actually happened is you go look at the amount of compute available, even like for chips, it's actually continued to trend up because now what we do is we build systems that have multiple chips in them. So we have like both the scale up of a single chip and the scale out. And as a result, every year humanity has more and more compute available to it, right? It's the same thing with giant model scaling. Like the base model itself, even if the base model itself stops scaling at some point as you throw more compute at it, there's a whole new way to go make models smarter that is just being tapped right now. And that whole new way of making models smarter is not just making the base model larger, but it's by having the base model, basically by like having the base model collect data for itself to learn how to get smarter. So let me give you a concrete example of this, right? A concrete example of this is right now, let's say you want to train an LLM to get better at solving math problems. The way you do it is you collect lots and lots of like positive solutions to hard math problems, and you throw it in the data set, right? And you're like, hey, like model, go get smarter at this thing. But a much better way to solve this problem is you give the model that you're training access to a theorem proving and math environment, right? Like give it a Jupyter notebook. Give it there's a theorem proving library out there that a lot of people use as well. Like give the model direct access to those tools and then say, hey, I want you to experiment. I want you to go try solving this problem and then reflect on it. Like, did you do a good job? Like, is this problem solved? If no, try again. So now what you get to do is you get to have the model play with the simulated world, basically, to collect positive and negative data how to solve math problems. And then that makes the model smarter. So the second way of improving model performance is just starting to be tapped now. And that's also going to absorb a boatload of compute. So because of that, I actually am not worried about the diminishing returns to compute over time.
Why is it just starting to be tapped now? And what does that progression look like of its own development?
Everything's an S-curve, right? So the giant model scaling, base model scaling S-curve, for the last couple of years, we were at the sharpest point of improvement, right? Everybody could, you could double the cost of your model from $100 million to $200 million. And that would be the fastest and easiest way to deliver a smarter thing to the world. And now if you're getting to $1 billion training rounds and $2 billion training rounds and $4 billion training rounds, it's really freaking hard to go get more money to go make the base thing bigger. And so because of that, now the critical path for model improvement is shifting over to this sort of broader sort of simulation / synthetic / like RL loop sort of path. I think it's just a natural consequence of the fact that it's so expensive to just keep scaling.
Is it like reinforcement learning of its own data sets? Like where it just continuously repeats the same things until it gets it right? Is that a good understanding of it?
That is a good understanding of it. So I think a good way to think about it is historically, for the last couple of years, as we scaled up LLMs, we've just been doing more unsupervised learning, right? Like get more data, more smart journalists writing articles, feed it in there, and that makes it smarter. But the problem is like a model trained that way is only as good as the smartest data in the training set. Like it cannot discover new knowledge because its job, the way the models are trained, is to do what a human would do in that situation. But the underlying thing is if you want to go solve like really big problems, like prove unproven math theorems or like be able to like help you solve a creative problem at work, those problems are by definition things that are not in the training set, because it's either like a superhuman thing or it's a novel situation.
Is that why we haven't seen agent progression in the way that we wanted to or hoped we would? Because a lot of the tasks that people do are not actually codified in data. They're codified in conversations, in rooms, in whiteboards, but not in data.
But not in data. Yeah. I mean, I think that's a key insight. It's like I kind of think that chatbots like ChatGPT and stuff and agents are kind of becoming different species of technology a little bit, right? Like I think they'll be useful in very different ways, and what they need to be used for is super different, right? Like just one concrete example is the hallucination problem. Having hallucinations in chatbots and in like image generators is like a really good thing, right? Because it gives you like a starter tool for like getting to like solve the blank page problem, right? Like, and like gives you like little bits of novelty and creativity. But agents, on the other hand, like if you want something to go like consistently, I don't know, like do your taxes for you, or handle all of your shipping containers or something like that, you do not want that thing to go randomly hallucinate and like make up stuff along the way, right? And so like these things are speciating in an interesting way right now.
You mentioned to me before the minimum viable capabilities levels and how that is a function of model scale.
Yep.
Now, when you said that, I didn't have a clue what you meant. And so I was hoping that you'd be able to unpack it for me.
Yeah. Okay. So the coolest thing, the reason why I love working in AI is that like for the first time, you're as an engineer or researcher, it feels like you're like uncovering like unknown secrets about how intelligence works every day. It's like very different from programming. As a programmer, I show up to work, I'm like, here's the thing I want to build. I know I can build it. I know if I am clever enough, I can solve the problem. And I know exactly the behavior of the system that I've built will be. But the cool thing about AI is that every day you come to work and you make some tweaks to the model, and what you get on the other end is actually somewhat unpredictable. Like you kind of feel more like a gardener than an engineer. And I think what's really cool about it is that like, as these AI systems have gotten bigger and as the architectures and data sets have improved, what the model is good or bad at, you can't totally predict ahead of time. You have some estimates for things, but just going back to the early days, right? When we were training GPT-2, we trained GPT-2 at various different sizes. And at the smallest size, the model was just like unable to do 3-digit arithmetic. But as the models got bigger and bigger and bigger, we didn't change anything else. We just had it look at more data, and then we made the model bigger. And then like at a particular size, there's just an aha moment where it went from not being able to do like 3-digit arithmetic to being like very good and predictably improving at getting 3-digit arithmetic better. And that like aha moment we couldn't know about in advance. So that's what I mean by like minimum viable capabilities and how it's a function of model scale. Like if you there are things that we really want these models to be able to do, like be really useful agents, or to help us discover new things in science or whatever. But it's hard today to say, hey, if I just spend like $2 billion in compute on this model and have the right data, that'll happen for sure. I think that's what's so cool to work in the field.
When we think about like actually improvements in models, they lead to improvements in performance. And I kind of think there's 3 ways of doing that. One of which is like a breakthrough in reasoning. How do you think about the likelihood of a breakthrough in reasoning? What's required for that? And whether that is a reasonable expectation?
Reasoning is one of the problems in the field right now that I think a bunch of us sort of have similar ideas for how to solve, but it actually requires some new research to be done. So in a weird way, working in AI is pretty funny these days because the giant model scaling problem is so known. And it's really a function of resources. And so you kind of don't feel like you need to be a genius to go make new progress on just pure model scaling. But I think pure model scaling does not deliver solutions to reasoning. To me, the definition of reasoning is being able to like compose existing thoughts to discover some new thought, right? And I think to go do that, that's not something that's trained into the capabilities of LLMs by simply asking it to regurgitate the internet's worth of data. The way we're going to solve reasoning is back to what we were talking about earlier, of like taking theorem proving as an example. You want to give the model access to a theorem proving environment and have it try things. In the same way that, like, as a human mathematician would sit down and be like, well, here's the things I know to be true about the world. How do I compose them such that I can prove the thing that I want to prove?
Is it not the model providers who will be the ones solving reasoning, or is it actually the end kind of consumers or vendors who will be leveraging proprietary data sets to then utilize that to solve reasoning? Which one's which?
I think the general capability of reasoning will need to be solved at the model provider level. And that's because what you're actually doing is you're not just using the model to reason, you are trying to improve the model's ability to reason, which means the model itself needs to change.
Does that mean that we're not going to see the commoditization of models? Everyone talks about this commoditization. We're just going to switch between them. It's going to be a race to the bottom. Does reasoning mean that actually that won't happen?
No, I actually think that I think that, like, solving these reasoning skills are on the roadmap of every LLM player. I do think there will not be that many LLM players. I think that there will probably be, my guess is somewhere between 5 to 7 long-term steady state LLM providers at maximum scale, just because of the costs involved. Reasoning is just another expensive thing that these companies have to get right, but I think they will all solve it, because I think the way to solve reasoning is something that many of us in the field kind of have a pretty strong suspicion on.
What is your strong suspicion on how to solve reasoning?
It's what we were talking about earlier. It's train a base model, give it access to a wide range of different environments to go solve hard problems in, and have the model try how to solve those problems, and use that and combine that with sort of human input on whether it's doing a good or bad job. And I think that will solve reasoning.
Why has no one been able to solve memory? People often talk about this, and respectfully, it seems a confusing one to me, because it's like computers have memory anyway. Why in AI is memory such a challenge?
You can kind of think about memory as being two different things, right? You kind of have short-term working memory, and then you have long-term memory. I think people have made really good progress on short-term working memory, right? Like, if you could look at Gemini's context length is like 1 million. It might even be more now. I actually don't quite remember. Like a million tokens long, which is so cool. Is you can feed it like giant snippets of video and be like, hey, like, write me a step-by-step of like everything the person cooking in this particular video did, and it'll do it. Like, that stuff is insane. Like, that's making good progress, and the reason that's been hard is for computational reasons. But I think this sort of longer term memory problem, this goes back to like another thing that I believe, and that's why I'm excited. I'm slightly less excited about model building, slightly more excited about application developers, because the underlying thing that everyone's realizing now is that LLMs themselves are not a product. Like, an actual product is this entire software system that uses LLMs in it. So, for example, like, what we should be doing is we should be finding ways in which like end application builders can be themselves responsible for how to build in long-term memory about user preferences, right? Like, I don't know, just to choose a random example. I'm working, let's say I'm building a company that's working on a sort of consumer travel assistant, right? Like, I should just be able to tell that thing, hey, like, I freaking hate, this is a true story, by the way, I hate aisle seats because once someone dropped a suitcase on my head on a flight and I got a concussion. Never book me an aisle seat again. Like, that kind of like long-term memory, I think application providers should be able to handle as part of a bigger system.
I mean, I love that in terms of also LLMs not being products in themselves. Yeah. You mentioned 5 to 7 core providers winning. What will separate those that win versus those that don't? Is it purely a game of resources and cash?
I think it's a game of how much you existentially need to win. I think every cloud provider, every tier 1 cloud provider existentially needs to win here, right? Like, let's look at the dynamics involved. It's one where, as these models get smarter and smarter, they kind of become the base computing primitive. Like, today, the base computing primitive is like nodes on EC2 or like storage, right? But in the future, when more and more software is just like the logic of software is actually just handled by an LLM, nobody cares anymore about what the base computing primitive is. All you need to do is access these models and compose these models to go solve things for customers. So then whoever controls the model layer controls all of the underlying compute. And so, like, right now what's happening, right, is if you don't have an offering here, then that is state of the art, then you're just going to be cut out of this particular game. I think this is also actually an area where I think it's really important for companies like Nvidia to go up the stack, right? Like, Nvidia clearly killing it right now on chips. But what's happening is every one of the major clouds is working on, and every major LLM provider is working on a strategy to have their in-house chips, because that way they have better margins. And so then at the end of the day, if you're like a developer or you're like an end user talking to ChatGPT N from one of N different providers, do you care whether the backend is an Nvidia chip or an AMD chip or an in-house chip from Google, right? You don't really care. And so therefore, like there's like a really key point of the interface to the LLM gives you tremendous leverage on everything downstream.
So do you think we'll see the ownership of the vertical stack? We saw Apple talk about their own chips being a prominent part of their new releases. Do you think we'll see Nvidia, really move into the model layer with prominence, but also the model layer move into the chip layer with prominence, and both try and eat each other's lunch from different ends of the spectrum?
That's my expectation. To me, like what's interesting about AI from a business side, right, is like it forces the question of like what companies or offerings are going to be bundled or integrated and which ones are going to get unbundled. And I actually think that there's going to be a really strong vertical integration pressure between model builders and chip makers.
Can you just unpack that for me? Keep going with that thought.
I love the topic of chips. We can stay here for a while. It's so much fun. It's like the most interesting thing that's happened in some time for that industry. Like we were just talking a minute ago about how important it is, right, for model makers to control their chips, because that way, if it really is a scale and resources game, if company A, let's say choose Google with TPUs are great, right? With TPU has a 20% cost advantage compared to company B using chip Y, right? Then Google will just be able to their better cost of model training will let them go bigger, let them invest more in post-training tricks like the ones we were talking about earlier, and have an advantage. And so then company B is like going to be really pressured to go find some way to go do that themselves. Similarly, if you're a chip maker, if you become like, it's just too easy to be commoditized by these in-house efforts if you don't also own something at the model layer.
Is it easy? Like when you think about Nvidia and what they do, is it easy for them to be commoditized? Is there not such sophistication that actually it's incredibly hard for these people to move into the chip layer and take that lunch?
Okay, I actually think we're saying the same thing. It is incredibly hard. Like Nvidia is killing it. It is incredibly hard, but it is possible. And if the economic returns are high enough, people will do it, right? So I just think Google TPU is a great example. Like I'm a massive Nvidia fanboy. Jensen is incredible, like brilliant guy. I think Nvidia has like executed so well here. I think we also have to give props though to like, I think the TPU team when I was at Google was like sub 500 people, and their budget was a shoestring budget. And yet somehow every generation they taped out quite good chips that were then used to train Gemini and Palm and are used by third parties now and all of that stuff. And like there is such a strong will to ensure that Google has its own first party chip that I think that's like the counterexample to like the perpetual chip dominance.
I had someone say to me that actually Apple are the kind of the dark horse in the race, because they own obviously the consumer and the end device, and they can actually run models offline on everyone's device without reliance on anyone. How do you think and feel about that?
Thinking about the Apple, think about like the Apple advantages in this particular space. I think there's like two areas of like extreme power and leverage that you get in machine learning right now. One is the ability to run smart models for free at the edge. And the other one is to have the absolute smartest models possible. And so I think Apple has a massive advantage on the former. And when we go think about like what, whether that'll be enough, I think that's a really hard question to think through, because I kind of think about it as like concentric rings of model capability, right? To give some concrete examples, like a 1 billion parameter model that is otherwise trained to be state of the art kind of has like this set of capabilities that it's like perfect at. and then it's like kind of okay at the next rung up. So like maybe the very minimal set of capabilities is this tweet positive or negative, right? Like you don't need GPT-10 to go tell you whether this tweet is positive or negative. Like a pretty small model can do a perfect job at that. And so things like that will always run on the edge. And so then if you're a giant frontier model provider, like you're just not going to be able to monetize these like tiny skills that are just going to live at the edge. But then conversely, like a billion parameter model is probably for some time not going to be able to create a 3D part for me for my car, right? That's probably going to be the like GPT-10 problem. And so I think as a result, I think Apple is just going to completely crush at everything that looks like something that's really private, something that's fine-tuned on your own particular data, but doesn't require massive reasoning capability. And that will all run at the edge.
Can I ask you, I was quite shocked by Apple's partnership with OpenAI in terms of the looseness that they tied to it. They continuously said, oh, but we'll actually maintain relationships with others. And they very much left the door open to switching between different providers. I almost thought it was a net negative when I heard it. I'm just intrigued. How did you interpret that when you heard it?
I am extremely impressed with OpenAI. I think in terms of their technical delivery, I think the degree to which GPT-4o was like, I think relatively underhyped relative to what I think the true scientific improvements have been in that model, is there's a pretty big gap. Like I think like we're moving towards a world where we're going to be training these like universal models that take any input in, right? Audio, text, video, you name it, and then generate any output out. And all of humanity's knowledge will be encoded in one of these models. And I think GPT-4o is a much bigger step towards that than people realize. So I think that Apple cutting that deal with OpenAI, I mean, of course, I'm not privy to what actually happened, but I think at least part of it is a recognition that I think OpenAI is on a different trajectory compared to others on actual model progress. But at the same time, it also really strongly hints at a commoditized future. Like to the same extent today, as a consumer, I no longer care whether my computer, my desktop at home is powered by an AMD or Intel CPU. I think trying to create a way in which Apple owns the interface and Apple owns the end customer, and then the like big brain LLM smarts is just like one hot swappable thing is brilliant for them.
What do you think the end state is for the foundational model layer before we move on to the application layer? Like, do they just get bought? You know, you've got a couple of core ones, which is really Anthropic, Mistral, who have raised a lot of money, billions, and bluntly will not have the resources to compete continuously in the tens of billions of dollars needed. What happens to this layer?
I think what happens is all of the tier one clouds will have their own effort that will do well because it has to do well. And they will do whatever it takes to go ensure that they have the capital and data flywheel and talent to go do that. Then I think for the independent companies, and I would say that Adept is very different because what we do is we sell an actual end user facing agent to enterprises, which is a very different business model than selling models to developers. But companies that sell models to developers will either need to effectively be the like first party effort of one of these big clouds, or they have a short window between now and commoditization to build such a big economic flywheel that they can afford to stay independent.
How could you build such a big economic flywheel, just so I understand, like an amazing enterprise go-to-market that generates $5 billion of free cash flow?
Yeah, I think it would have to look like something like that. And I think that right now, that's why I think of the companies, of the independent foundation model companies, besides Adept, I'm more excited about places like OpenAI because they have ChatGPT to help do that. Whereas I think if you're a pure play model seller, I think it's very difficult.
Maybe it's the pain and the lack of anesthetic, or maybe it's just my naivety.
Sure.
But I'm not afraid to ask this one. Would you say Adept is a foundation model company, or would you say that actually you are not? How do you think about the positioning?
We're actually just focused. We're really, really focused on this particular problem that we're trying to solve. Like we're trying to build an AI agent that you can delegate arbitrary work tasks to, right? And so then everything we do stems from that. So what we are not doing is we are not trying to just train foundation models to sell them to other people. What we're doing is we're building like a very vertically integrated stack. Going back to our previous discussion of where will vertical integration happen versus not, I do think that in the agent space, it's extremely important that you own the entire stack from what is the end user interface. I think, like we were talking about the Apple example earlier, owning the interface gives you tremendous leverage in this era of AI, to how do you make agents that are reliable enough to be used at work, all the way down to what needs to happen to the foundation modeling layer to enable this whole end-to-end system to be maximally performant. That's what we do, is this vertical slice.
How do you think about the variation of agent requirements based on a per industry basis? If you have do you know what I mean? That's so varying. It's completely different.
Yes, and that's what our advantage is. That's what our advantage is like, we get this question all the time, right? With Adept trying to build something that lets anybody, like we want to be the system of record for workflows in enterprises. Like any employee at any large company should be able to teach Adept, hey, like here's how I do this particular thing, right? Like here's how I handle here's how I handle fetching all the data for an insurance claim, right? And they should just be able to show Adept that, and then Adept should be able to do it for them. And like that generalization, all of those edge cases and variability is why the only way to solve that is to have vertical integration of model with use case. And it's also why I think we'll do better than companies that are just focused on a vertical, like a particular narrow problem. Because I was talking to Parag, who used to be the CEO of Twitter. We were just hanging out the other day, and he's like, dude, every enterprise workflow is an edge case. And he's absolutely right. And that's why you need to control it.
What does he mean by that? Can you unpack that for me?
I mean, just even looking at something as simple as, like, I want to add a new lead to Salesforce, right? Let's go outside and find 10 different companies who all use Salesforce and look at how they've got it configured, and it all looks completely different from each other.
Yeah, I get that. Can I ask you a dumb question again? Is this not what RPA was always meant to be? I'm friends with Daniel Dines from UiPath.
Yeah.
Wonderful dude.
Yeah.
I always swear this is what RPA was. So can you help me understand the distinction between like traditional RPA, which is what we've seen with UiPath, and this new era of agent that we see today?
Yeah, totally. I mean, this is a good question. It's actually a question that used to cause me a lot of heartburn because I found it so hard to explain to people why agents were going to be different than RPA. Best analogy I've got is RPA is very useful for high volume tasks that always look the same. So the analogy that I would give would be like RPA is a little bit like when you go to a factory floor and there's robots roaming around everywhere. What those robots do is there's like literally a yellow line painted on the floor, and the robots like follow that line. They go from cell to cell and station to station, and they pick up stuff. But what agents are meant to be constantly thinking and reevaluating and planning at every step to solve your goal. And it's much more like full self-driving. The difference in utility between those two things is fairly large. Of course, there's many areas where you don't want something that can have variability, and therefore you should use RPA. But I think the majority, I just think in 5 to 10 years, people are going to use their computers by giving them high-level goals, right?
So will the largest enterprises in the world run RPA and agent-based systems alongside each other?
I think so, yeah.
Why are RPA players not best placed to provide an agent solution to existing customers?
I think it's just really fundamentally disruptive to their business model. The way that a big corporation uses UiPath, right, is like there's a big plans around a process transformation that needs to be done. Sometimes like an Accenture or something comes in and then maps out what the processes are like. Sometimes with a process discovery thing, and then RPA engineers go and build those workflows, and then 6 to 9 months later, you hit play on this thing that then automates some invoice processing every night or something like that, right? Like this new model of you just put an agent in there and the agent observes what the end user does to go do that job, and then that becomes like a thing that you can then just invoke with natural language. It's like really disruptive to the business model, and I think that the best way to run circles around incumbents is to do something that has a different business model than what they have.
How's your business model different?
The way that we're doing things is we are addressing use cases initially that are really painful, that get our foot in the door, but we're really focused on how do we make the end user be able to teach it any new capability. Like I should be able to dump in to Adept, I should be able to dump in my standard operating procedure for this new thing my team does, or I should be able to show Adept 10 times and give it corrections on how I how I enroll a new nurse into a healthcare portal in the US, and then the model should be able to do that for me. And basically we're working on something that's ultimately very self-serve over time.
Everyone speaks about kind of we're going to sell the work and not the tools. It's like the hottest statement. And the end of price per seat, and we're all moving to a consumption-based pricing model. Do you agree with that statement? Do you think we're all slightly overemphasizing like the end of price per seat? And how do you feel about this kind of fundamental shift in business model and pricing that AI could bring about?
I think in places we're definitely going to see that become true. But I actually think in knowledge work, the most valuable things to do will not be priced that way. And here's why. I think that like the definition of price per work assumes repetitiveness, commoditization, cookie cutter, like no creativity, right? But the way that like I think what these AI systems are going to do, especially AI agents are going to do, we are basically going to like give people the ability to go do new things and have way more leverage on their time and like give them more opportunities to be creative. And so then ultimately what we're building is like a co-pilot or a teammate. And co-pilots and teammates don't charge you price per work. They like you really pay them based on their ability to augment your ability to go do new things, right?
You mentioned that the kind of co-pilot approach. I had the guests on the show say that the co-pilot, and I think it was Miles Grimshaw at Benchmark or Now Thrive, said actually co-pilots is an incumbent strategy. It's leveraging existing distribution and it's an incumbent strategy. Is that fair, or do you think actually it's not giving due credit to the co-pilot approach?
I think both of these two things can be true. Like I think co-pilots are a great incumbent strategy because it lets them morph their existing software business model into something that kind of looks the same while getting in on the AI thing. But even separately from that, I just think like, where are these systems going to be most useful? Like, I just feel like everybody in this field has this vision, right? That like AI is going to take all jobs. The like pricing by work thing is just a corollary of AI is going to take all jobs, right? Because then it's like, all right, maybe you price by work on invoices, and then next month you price by work on like consulting decks, and then before you know it, you price by work on like being AI CEO of like David Co. or something like that, right? Like that's not. I don't think this is how this is going to play out. I think the way this is going to play out is that where we're going to have as humans fundamentally be the drivers of these agentic systems that basically give everybody a tremendous amount of leverage on their own creativity. And like, how can that be built without a co-pilot style approach? It's like my question.
What does that do to the org structures of teams, David, do you think? Does this mean much, much smaller companies? Does this mean, how do you think that actually plays out?
I think the main way it plays out is actually, this is something I'm going to steal from our angel investor, Scott Belsky, who has just thought about this so much. He always calls it like this collapsing the talent stack thing. And the idea is basically that, or this is my interpretation on it, like projects and teams where the same person is simultaneously the PM and the designer and or the engineer or the go-to-market person or the marketer or whatever, like the more that like those different skill sets are smushed in the same person, the faster that thing moves and the more effective the thing becomes. So I think what it's going to do is it's going to make humans at work much more like generalists, and it's going to have like cause us to create larger and larger or giving people sort of like larger and larger scope over various different like areas that are different functions today, while they ultimately supervise like a cohort of like AI co-pilots that are the specialists.
One thing I did want to touch on was when we think about the rollout, I think we overestimate enterprise adoption. One, are we still in experimental enterprise adoption budgets, or do you think we are moving into core enterprise adoption budgets?
I think, Harry, we should rewatch this podcast in 10 years. And see how we feel. But I think like, when we talk about AI, like AI is so freaking broad. It's a little bit like us asking, maybe in the early days of the internet, a generalized thing about the internet as well. Like it's just, I think there are some use cases that are clearly hitting PMF within an enterprise. But for the most part, like just when we go to enterprises to go sell them stuff, like they've got so much stuff that's still on-prem. They've still got workflows running on mainframes, and it's 2024. And so I think like even if technologies like cloud, which we probably look at as from a startup lens as being so freaking mature, still doesn't have full adoption in enterprises, is like I think that stuff is really interesting. And I think as a result, like we're going to be on this adoption curve for enterprise AI for a very, very long time.
So we are still in the experimental budget phase.
I think the majority of it is like extremely experimental. Like one of the things we do, for example, is we really try to not sign deals that are coming out of experiment budget because we want quality revenue, basically.
Do you think we grossly overestimate enterprise adoption in the short term and underestimate it in the long term?
Yeah, I think it's true for most new technology, but definitely here.
I love Alex Schultz, the CMO at Meta, told me and recently released a piece about kind of hype cycles in new technology. And actually, he states his kind of concern that AI will replicate autonomous driving in the way that we got so excited about 10 years ago. Everyone's going to be unemployed, 8 million truck drivers. But my question to you is, are we going to see that similar plateauing where for 10 years, actually, kind of autonomous cars didn't feel like it was progressing? How do you think about that?
I've never worked in self-driving, but if I'm gonna apply a mental model, and you tell me if it lines up. I feel like in self-driving, what happened was there was an aha moment where you could get the thing to work at all, and then you're like, okay, well now it works 60% of the time. How do we get this to 99.99999% of the time? And every day you show up to work and you just play whack-a-mole on what's not working. And you just like hope and pray that this converges to that like 99.99999 thing. That's not true for AI right now. That's not true for specifically what I'm about to say is only applicable to building smarter and smarter models and agentic systems that ultimately help you do work. That's the thing that I'm trying to talk about. Like for building that, that's not how the underlying dynamics are right now. Like every day we go to work and there's like actually brand new scientific things we want to try that just dramatically improve the performance of the model. And some of those bets don't work and some of those bets really work. I think like the reasoning that we talked about earlier is an example of one. I think another example of one is like this like universal multimodality that GPT-4o is. Like those breakthroughs are like visible. And as a result, I think the what's going to prevent this, for what I think has a hope of preventing this from just being a hype cycle that falls flat like AV, is that those shoes are yet to drop. And as they do, the capabilities of these models are going to continue to improve. And that on top of that, there's not a technology that you like need to get to that level of reliability before it can be deployed. It's already deployed today.
Speaking of deployment, I think, and the kind of enterprise adoption, I tweeted actually that you would see AI services companies, really people who help in the implementation of AI in large enterprises, be bigger than the model providers themselves in terms of revenue. And we've seen that actually come out as being true. Yep. I had some famous people call me an idiot, which actually made me quite pleased when those revenue numbers were revealed. How do you feel about implementation providers, AI services providers, being bigger than the actual providers in the next 5 years? Do you think that it's right that the biggest players to come out of this cycle will be the AI services providers?
I don't think so, because I think the third bucket of like economic upside is still early, and I think that bucket is like is the companies that then turn the use cases that have product market fit into repeatable products. Right now, right? Imagine you're very large company X, right? And you need capability Y. And then you've got the base model over here, right? That's pretty darn smart, GPT-4 or Gemini or whatever, right? And there's a giant gulf in the middle. Like I feel like in every one of these cases, the first people to go fill that gulf are like sort of consulting-y service providers, right? But then the moment that gulf starts getting filled, you start seeing, okay, like this is the really useful thing for an enterprise. Then people just go productize that thing, and then that becomes a startup. And so then that becomes eventually a company that's a conduit between the base intelligence and the customer. So today that might be true for services, but I feel like a lot of these things will be turned into generalizable products. And then when they do, those companies will then be the real economic winners.
One other concern that I have two other concerns, but I want to touch on both of them with you because they keep me up at night and I have enough wrinkles, David.
I love that you also write them down as well. So
do you know what? It's important. My memory goes, okay? It's the challenge of being old. But regulation, Europe, specializes in it. One concern that I have is that we could regulate ourselves into oblivion around data usage, data collection, and actually we don't see the progression of these models and AI in a way that we want to. How do you feel about that? How likely is that? What would you like to see happen in regulatory environments? Help me sleep at night.
I think my main concern right now is actually one of regulatory capture. In the same vein we were talking about earlier about how there will be only a few sort of frontier model companies that can exist steady state. I think the move to go pull up the ladder behind them is already beginning. And I think that lawmakers don't really understand this technology at all. And so their default instinct is sort of listen to the most credible source. And usually those credible sources have alternate sort of ulterior motives here.
So what happens in that case?
It becomes harder for the general field to go build on open source. It'll become harder for new companies to get started that have new AI ideas that they want to go train and scale up. I think what really happens is just another concentration of power moment.
Ironic given Lena Khan's position. Okay, that is a concern for me. You mentioned kind of the ability to build on open. The other concern that I have is actually, we had Alex Wang on the show, and he said, I think that, what was his statement? His statement was AI is more powerful than nuclear weapons. And in the hands of the wrong people, especially AGI, it could be probably the most lethal weapon used ever. And for that reason, we should probably have more closed systems. How do you think about that debate of open versus closed, and whether for some of the most crucial decision-making AI systems, it should be closed?
I think two things. One, I think the broader set of concerns about use and misuse and safety are extremely important. And I think that what was a good thing about all of this is that people are having these discussions more openly, which I really strongly appreciate. I think with a lot of these systems, you can already see clearer ways to go misuse them, right? Like spin up a bunch of servers, take the best code model you have out there, use them to go try to find vulnerabilities in software systems. If that's already happening, it's going to really start kicking into gear. So things like that, I think, make me very concerned. At the same time, I think that AGI is just a really difficult thing to reason about, because the way that many people define it is almost defining it as an infinity. And reasoning about infinity is really hard, because you multiply infinity by 0.0000001%, and that's still infinity. And so I think it's a very brain breaking thing. And so I think a better way to go look at it is to look at the path dependence. How will this technology actually be developed in the next 5 years? And I think in the next 5 years, open will always lag closed. And because open will always lag closed, because open just has fewer resources behind them and fewer incentives for people to go make things to be open as these things become more and more expensive, I view open really as a way for the rest of the field to keep up with the biggest incumbents. And therefore, I think it's actually pretty darn important.
You mentioned kind of AGI being kind of infinity there in people's minds. You said before to me that the last step is human-computer interaction, and that's the last ingredient to AGI. Before we do a quick fire, what did you mean by that? I didn't get that one either.
I personally find a world in which sort of increasingly generally intelligent systems run around with their own agency and goals, and not involve what humans most care about, to be not a world that I really want to live in. And this goes back to what you were saying about selling AI by work versus as a software tool, right? I would much rather live in a world where we have sort of these AI teammates and assistants that we interact with instead. And then I think the question becomes, how do you find the right interface between smarter and smarter AI systems and people? And how that interface is defined actually changes a lot about what training data you collect. How can humans align these systems towards the preferences of what humans want? Also, ultimately, how these models are even built and what their architectures are. And so in a weird way, the way the field is moving is, let's make models smarter, and then let's make use cases smarter, and then let's go put them in people's hands, and then let's figure out what this means for people. It's kind of this waterfall sequential method, which I don't think is a very good way to develop the technology. I think we should start back from ultimately how should humans use these things, and then create the whole solution end to end that way. And so that's why the HCI problem, people just aren't spending enough time thinking about. Chat is obviously not it.
You mentioned that kind of the wrong way to think about it. What questions do you think people are not asking enough that they should be asking more?
As these models get smarter and smarter, and they sort of know more and more about the world and have more and more ability to do things in the world, how do you interact with them? How do you supervise them? How do you give them corrections and teach them to be more aligned with what you want? I think questions like that I'm sorry to be blunt. Is that not just basic prompting? when you go work with a coworker, right? You don't just talk back and forth. You like actually like share the same canvas. You'll go use a whiteboard. You'll go like maybe look at the same thing on the computer together, and then go try to solve the problem together. Like human interaction is like way richer than like writing a set of instructions and then being like, do this thing, and then when it fails, you come back and you tweak the instructions a little bit. Like that's just not a very like, especially as these systems become more and more smart, that's just a really bad way to go interact with them. And we're just not putting enough time to figure out the right way in which we interact with these things.
Listen, I've peppered you with questions. I want to move into a quick fire. So I say a short statement. You give me your immediate thoughts. Does that sound okay?
Yeah, sounds great.
So what have you changed your mind on most in the last 12 months?
It's actually a little bit of what we were talking about earlier. I actually think agents and chatbots are going to speciate and turn into two different products.
How does that look?
I think it's going to look like you're going to have these like rich interactions with these increasingly smart systems that can do things on your behalf. And then you're going to go have other systems that you talk to for like therapeutic or fun use cases.
What's the biggest misconception people have today of the next 10 years of AI?
Biggest misconception is that this is just going to be something that at every step takes another human capability and fully automates it. Like the implicit goal of AGI right now is replace human work, but like so much of human work, like I just don't think will be neatly captured by AI. And instead it's going to be something that like, it's just like AI will be a tool to level up human intelligence.
What's your vision for the future of agents? If everything goes to plan, agents in 5 years' time are ...
Agents in 5 years' time, I mean, it's kind of going to be like a non-invasive like brain-computer interface, basically. I think that's what an agent will be. Like all of us are going to be up-leveled. We're going to, it's going to feel like the same transition from like DOS/command line to the GUI, but from GUI to agents. We're going to interact with them at a high level, at the level of goals. And they're basically just going to let us, I think, they're going to let us like have like basically like new kinds of thoughts, like the ability to go like reason at one level of abstraction beyond what we all do today.
You're writing a pre-mortem on why that does not happen, why agents are not that in 5 years' time. What is the most probable reason why that does not happen?
I think one way it won't happen is that incumbents have so much, like fundamentally, like agents are a reframing of like how software is bundled, right? Like today we bundle software in these like functional ways, right? Like you've got Notion or Google Docs for your docs, and then you've got Salesforce for sales, and then you've got like WorkDay for HR and all of the stuff, right? But the work that we do fundamentally spans all of these different domains, and an agent should bridge those domains. Otherwise, you can't become a higher level thing. So if we're locked into like end walled gardens by incumbents, then that vision will not happen.
This sounds super awful VC mindset, but when you look at like UiPath today being like a $6 to $7 billion company, do you not think there's bigger opportunities to go after? Like that took 17 years, maybe more, 19 years. And it's a $7 billion company with billions in revenue. You're a super smart, super ambitious guy. That feels like a lot and a long time for actually a value capture that, if done well, is still like.
Well, I think the question is, what percentage of work done today is addressable by RPA? It's very little, right? But what's the percentage of work done today that's addressable by agents? It's like 1,000x that. Maybe 10,000x that. I don't know, something in that order of magnitude. It's just it's a very different market. It's like saying, should we work on self-driving when self-driving didn't exist, and then looking at the market for those autonomous rovers and warehouses.
David, honestly, shows like this are why I love doing this. So thank you so much for being so brilliant. I so appreciate you putting up with my lack of smiles, but this has been fantastic.
No, you're doing awesome. The fact that you're able to do this after a wisdom tooth removal is insane. I had so much fun. I thought you asked great questions across business and tech. I'm excited to see how this all plays out from here.